Okay, last video, short one too. So we figured out the time total, and now the last part of this, it says how far did it go, meaning the hammer, in the x direction. In the x direction as a total. So there's two ways of doing this. You can either break it up into the individual parts, like that, or you can treat this as a whole condition, saying, like, you could do initial and then end, and then initial and end, and then add them together, or you could say initial and end where it's landing. Okay, and that's what I'm going to choose to do. I'm going to have this be my initial and where it lands be my final. Okay? If that's the case, then x initial is at the origin. So it'd be 0 meters. X final is what I'm solving for. Velocity initial in the x. Now the velocity initial, though, you figured out way back on part B there, was 400 cosine 20 meters per second. The velocity final in the x direction is the same as the initial because the acceleration is 0. There's no change in velocity, okay? And so that's why I can choose my initial position to be at that, base of the cliff, and my final to be where I land, because this doesn't change throughout the problem. It stays the same. This stays the same. And then the time total, we just barely figured that out. I'll use the long number. Okay, so I need to pick an equation where I know everything except for my unknown, so it has to have x final. There's a couple choices here, but there's one that actually becomes very simple. That third one, now we say, well, that looks awfully long, but it simplifies so much because x initial is 0, acceleration is 0, so anything multiplied by 0 is 0. So what I'm left with is x final is equal to velocity initial in the x direction multiplied by that time total. So we just have that 400 cosine 20 multiplied by that time total, and that will tell me how far it went in the x direction. Okay, and I got a long answer of 10,672.7 meters, and then this is about, for 3 sig figs, 10,700 meters. All right, that's the end of Thor's hammer. So, quick recap. Centripetal force equation for this first one here. And then we have using the y direction to figure out that maximum height of the hammer. We're going to keep this long number because we use it quite a bit. Finding the potential energy equation, just recognizing what I'm plugging in here. And then it's similar, just finding all the components for the gravitational equation as well as the force electric equation. The one thing here is just recognizing what's the difference between the hammer and the cloud. We forget that often. Most students, I'd even say, give me 2,500 meters, and that's not the case. And then we use both the first section and the second section in the y direction to figure out the two times, time of the first part, time of the second part. We add them together to get our total, which we can then use to figure out where the hammer's going to land. Okay, wonderful. Let me know if you guys have any questions. I'm happy to talk through any part of this with you.